the video. Today we're going to talk about memory uh, for basic primitive integers. We're going to talk about how memory works with one-dimensional arrays, and we're going to talk about two-dimensional arrays as well. So let's start with this. If you look at the right-hand side of the screen, what I have is a graphical representation of what a memory may look like for integers. Now, as we know, memory is the smallest addressable unit in a memory is a byte. So we always deal with memory in terms of bytes. Now, in most systems, an integer is worth 4 bytes. So when we talk about integers, what we really talk about is those 4 bytes combined, and not those 4 bytes individually. Now, how a particular data or number is stored in these 4 bytes is a different discussion that depends on what kind of system you're working on. But essentially, these 4 bytes are considered one integer. So when I say integer my age, for example, then this reserves 4 bytes in the memory. And because that is the case, when we go on and start talking about integer arrays, what we really look at is one memory location as 4 bytes. One integer is 4 bytes. So if I just declare an array, just like we did in the last video, a one-dimensional array of size elements, then what I need is a global variable size or a constant. So there are a number of ways you can do this. You can say constant integer size equals to, let's say, 5, or you could say you can basically define it using a preprocessor directive. So you can say define size 5, sorry. So now my array size is 5. I can actually go ahead and initialize it. So 23, 1, 2, 78. So these are 5 integers that are present in my array. And if you think about this, if I update my array, this is 4, this is 23, then I have 1, 2, and then I have 78. So this then is index 4. So I have 4 elements in my array. As far as I'm concerned, this is my array. Okay, now think about this. Indices go from 0 to n minus 1, or size minus 1. What is this? Whatever the size of the array is. And memory addresses. So we talked about this. An array right here means that my array points to first memory location in the array. So technically speaking, my array, this, points to this memory location, the first byte at index 0. So then, as we talked about this earlier as well, we can basically put it in a single for loop, and that single for loop can be used to actually go ahead and parse through the array. No matter what you want to do with the array, you might want to just add 5 to each element in the array, or you can basically want to change the entire value of the array. It depends on the application that you're trying to use. So next, what this video is really about is nested for loops. So what I'm going to do is I'm going to declare my array as a 2-dimensional array instead of a 1-dimensional array, and I'm going to say my globals are rows, which are 3, and again define columns 3 as well. So I have 3 rows and 3 columns. I will just go ahead and put rows in the first one and columns in the second one. So this is my array. I showed you in the last video how to actually initialize this. I'm going to go ahead and initialize this now. So 1, 2, 3, for example, for the first ones, a comma, and then we move on to the next one. And I'm doing this deliberately because I want you to realize that this essentially is a two-dimensional array. We are providing values row by row. So next up is 4, 5, and 6, and the third and the last row is 7, 8, and 9. Okay, so that's my two-dimensional array. Now I'm going to work with it as a matrix. So if you look at the right hand side, a 3 by 3 array visualized looks something like this. So you have your columns, you have your rows, row 1, row 2, row 3, you have column 1, column 2, and column 3. Now if you want to know which particular element in the array is where, you actually have to just play with the indexes. So index 0, 0, which means row 0 and column 0. So this essentially is not column 1, this is column 0, column 2, column 1 and column 2. This is row 0, row 1, and row 2. So next up, what we have is, so you can basically access each one of them. Now, let us go ahead and write a simple for loop that traverses through each one of these elements. So we did this in one of the videos earlier, but let's just quickly do this again. So my outer for loop has index variable called I is less than rows, so my outer for loop is taking care of the rows, and I plus plus. Then my inner for loop with a variable j takes care of the columns. Now it is important to know that these are merely numbers because we have given them meaningful names. They somehow make more sense because the names are meaningful, but technically speaking, because these are numbers, you could just replace them as well. Now if I just want to print all of the elements in the array, I can just go ahead, my I and j. So each time in the first iteration I is 0, j is 0, second iteration I is 0, j is 1, third iteration I is 0, j is 2, and so next, for second iteration for the outer for loop, I becomes 1, and so on and so forth. Now let's see how we can do this with some examples. So just disregard the fact that this is written as column 0, 1, and 2. Let me just write this again. The first example is about finding the sum for the first row in our matrix, and I'm basically going to call it a matrix because it essentially is how I visualize it. So how do we do this? Well, as you can see from this visualization, that sum of the first row essentially means that we're treating this two-dimensional array as a one-dimensional array, which means we're not really interested in the other dimensions. So what I can do is I can freeze the row at 0 and keep the columns moving, and that is what I'm going to do. So if I just freeze the row to 0 and keep the column moving, I can just work with it. So I'm going to again write a for loop, and because we are working in one dimension here, what you really need is one loop. You don't even need two loops. So let's say columns less than columns and I plus plus, and can you guess what the cout statement would look like? So it's my ARR. If you guessed that the second one is going to be I, you are right, because second one represents columns, and columns are moving from 0 to 2. But what's the first one? Well, we just sum the first one. We just fix the first one. What we're trying to do is to find out the sum of the first row and not print the first row. So what I'm going to do is I'm going to create an integer called sum, which will keep the sum for me, and I'll just keep updating it. So this will basically keep the cumulative sum. So I'm going to say sum is equal to sum plus this. So in the first iteration, this goes into sum. The second iteration, this is added to that, and the third iteration, this is added to that. Now, there's still something not right with this, and that is when I create a new memory location called sum, it will have some garbage value, and I don't want to start my cumulative sum with an unpredictable garbage value. So what I must do here is initialize this to 0, and this basically is your example 1, sum of one row of the first row. Now let's quickly move on to the second example. And the second example that we have is sum of the second column. So again, an integer. So because I already have an integer variable up top, I don't need to redeclare it. I'll just re-initialize it in a way. So I'm going to call it, I'm going to say sum equals to 0. Now, because we are now interested in one column and not any other row, so what I'm going to do is I'm going to fix columns to column 1 and move rows from 0 to 3 in my for loop. So for int I to 0, I less than rows, so I'm moving rows, and I plus plus, and then sum is equal to sum plus my ARR. If you guessed that this is where I is going to go, you are right, and if you guess that this is where you're going to fix the column, you are right. So this will be dynamically updated, whereas column 1 is fixed. So we are moving in one column. Now notice that we are working with a two-dimensional array, but we are working with a single for loop, just because of the application. Okay. Now third example is interesting, because in this one we are going to find out the sum of the diagonal. So do you think you can do this now yourself? You can at least try. If you'd like to do that, just pause the video right here, open a compiler, and do this. I think this should be a good exercise. Okay, so let's do this. Now, again, I'm going to reinitialize sum to 0. I'm going to write my for loop, and now I'm going to traverse rows and columns. But do you notice a pattern here on the column? Let me just write my initializer here. I less than, I'm going to just call it 3 for now. Okay, and I plus plus. Now, do you notice a pattern here? How many values are we summing? Essentially, we're summing 3 values. That's why I put a 3 here. There are multiple ways of doing this, but this is technically the simplest one. Okay, so the pattern here is that we are only summing where the value of row and the column is the same. So 0, 0, 1, 1, 2, 2. So this should not be that difficult actually. So sum equals to sum plus my ARR, I and I. If you guessed it, that's really good. So this should give you the sum for example 3, which is sum diagonal. Now, for, let's say, if you want to practice, try calculating the sum of the other diagonal. Okay. Another thing that you can do is try printing the first row backwards. Okay, so try this, and I'll see you in the next video. I hope this was helpful. Please hit the like button if you like the video, and thank you very much.